Hello world, welcome back to my holodeck. Today we're going to be continuing the Rockville Party Tower build. We're going to be focusing on these top speakers. Later on, you're going to hear a video and you're going to hear a comparison of a stock and modified Rockville RSG84 compared to a pretty high-end Funktion One F81. This is a pretty decent speaker that if you've been clubbing in the late 90s, early 2000s in some high-end clubs in New York and LA, they were always advertising a Funktion One sound system as if it's an amazing sound that you're never going to hear anywhere else. And you're going to find out it's a pretty mediocre speaker. It's just some standard PA speakers with pretty mediocre crossovers. Got a full range woofer and a second order crossover on the tweeter. That's just not, in my opinion, a complete crossover. You're going to have a 90-degree phase difference, and that's both of these. There's going to be a 90-degree phase difference between the tweeter and woofer in the crossover range. This leads to a less coherent sound, and it may not be as evident in the recording, but it's definitely noticeable in the room. Just instruments sound better when you have a complete crossover that helps dispersion and frequency response. And these are kind of the two main sound quality sound quality improvements that can be made to standard speakers. And these are standard speakers. They're just two-way 8-inch speakers, and you would think being similar, they'd sound similar. But with the crossover, they sound so much different. The one with the complete crossover really does sound different. Well, let's get into a little more detail in our slides. Okay, what we're going to be covering is basically the fundamentals of good speaker design. This applies to basically any type of speaker, but especially speakers that cover most of the range of sound that you're going to be hearing. In these tests, there's not going to be a subwoofer connected yet because we haven't covered how to build a good subwoofer. Right now we're going to be focusing on those top speakers, 8-inch two-ways. And like I said, even though they seem similar on the surface, the Rockville RSG84 and Funktion One sound very different in real life because simply they're set up a little bit different. They're both 8-inch paper cone pro style two-way speakers, but again, they couldn't be more different. Just the type of woofer, the type of tweeter, how they're implemented, even though like on the surface they all seem the same, they're really not. And you're going to also see kind of the mediocre to mid-range components in the expensive Funktion One F81. I'm kind of disappointed that they basically didn't complete the crossover. And again, we're going to cover that a little bit later when I show you some pictures that I took. But the first thing that it's just kind of obvious, we want a flat frequency response. We don't want a lot of bumps and dips in the response because that's just going to not make it sound as coherent. Then we have dispersion. This matters a lot, especially nowadays when you want people online to actually hear your music or your performance. If you're performing this live, if you're using this as a singer-songwriter in a bar and you got a guitar connected to it and you got a microphone to project your vocals, you want them to be able to whip out their phones. I mean, would be really nice if you were a karaoke DJ and people whip out their phones to hear a really good singer and they can actually hear the music and the vocals. And having good speakers will let you mix that live and record it live without any sort of direct feed or a special recorder. So people who just whip out their phones, they get a good recording. Another important aspect is microphones on phones and audio recorders are very sensitive to the phase alignment of driver output. Now this is a very complicated factor to try to compensate for. This includes your like THD, or total harmonic distortion, which is going to be mostly from resonances and dispersion problems. Yeah, THD can also include phase differences that cause beaming. That's when high frequencies tend to only be projected directly in front of the speaker and not spread out to the side. That has to do with driver selection. Some other stuff we're going to be dealing with a little bit later in this slide. But then you also have port alignment. These are ported speakers, and ports are also going to induce anywhere from 0 to 90 degrees of phase delay at the port tuning frequency. This is very particular because even though you're getting more low frequency output by porting your speaker, the output is going to necessarily be slightly out of phase, and this is going to have to be compensated for with a crossover that also introduces a 90-degree phase delay in around the same area as the port from the 8-inch woofer. This is again a little bit later when we cover subwoofers, but we still have to account for this because that port alignment is going to give us extra frequency response, a flat frequency response lower into the bass region, and that allows for a single driver to cover more of the human vocal range, which is going to increase the intelligibility of your speaker because a lot of musical instruments just also happen to be in the vocal range. That's like your saxophones, your trumpets, most of your synth notes, because generally human hearing is attuned to about the human vocal range. So all our instruments are generally tuned to about the human vocal range. Then there's also driver alignment. Driver alignment is physical alignment. There's a very particular way to align speakers, and the horns in PA speakers just happen to have one of those happy accidents that if you pick the right size horn for the right frequency, you'll actually get a time alignment correction within the crossover range between the woofer and the tweeter. That's really important because if you don't bother to complete the crossover, you don't get the 180-degree phase alignment of a real second-order crossover, and that allows you to simply reverse the phase of the tweeter, and throughout the crossover range and above, you're going to have phase alignment of all your high frequencies. If you don't bother completing the crossover, you're going to get that 90-degree lag, and it doesn't matter whether you move the tweeter forward or backwards. You may be able to time align one part of the frequency response, but the crossover is either going to be lagging or leading if you don't implement the 90-degree phase correction in both the tweeter and the woofer. So without completing the crossover, all kind of, I consider them hackneyed speaker designers are achieving flat frequency response, but not good phase alignment. And the phase alignment along with flat frequency response is what's going to give you a coherent sound. Then on top of all of that, you want a good impulse decay profile. And this is achieved with driver selection, crossover selection. I'm trying to keep the amount of reactive components in the crossover to a minimum, because I could be designing third and fourth order crossovers, but it starts getting really hard to get all the values right in the real world. I mean, you can do a crossover simulator, but with incomplete information on the woofer, it's easier to just get close enough with a second order crossover and just live with the minor phase delays instead of the 90-degree phase delay of just not completing the crossover. So impulse decay, also if you use sealed box woofers, the impulse decay from the woofer is gonna be a lot better. So we really are just kind of trying to pick and choose our battles here, and we're gonna pick and choose the easiest battles to win to be able to get a coherent sound, a flat frequency response, good dispersion, good phase alignment because of a few happy accidents that we'll be covering, and good impulse decay because we're keeping the crossover simple. It's a second order on both the tweeter and the woofer. So how are we going to achieve these? Well, like I said, good driver selection, and honestly speaking, the Funktion One does have a slightly better woofer. The paper's thicker. It sounds and feels to me like they're adding wool to the paper because it's a very British thing to do. It leads for a smoother sound where the breakup doesn't lead to harsh spikes in the higher end or the higher frequencies that the woofer is allowed to output because they didn't complete the crossover. But as a last resort, a lot of audio techs go, don't worry, just EQ it, and we can use DSP, and it's like, you can't use EQ and DSP to fix dispersion. You can only use it to fix flat frequency response and phase alignment of driver output if you biamp. But biamping costs more because now you need an extra amplifier, and you're going to need some sort of DSP or crossover, which just increases the cost so much more rather than implementing a passive crossover. And if you're running a 2.1 system, an active crossover on the subwoofer. That makes it really easy, actually. So dispersion, I keep making note of this dispersion, and it's because your audience isn't necessarily gonna be directly in front of your speaker. They may be off to the side, and you want to make sure when they pull out that phone to record like your performance that they get a good sounding recording. So this dispersion is really dependent on the compression driver, the horn. We're trying to eliminate like beaming from the woofer with a crossover, so that doesn't really affect our dispersion. It's really our tweeter that's going to be dictating the kind of dispersion that we want because it's got a fixed horn. I can't replace it on the speaker. In the real world, the ideal really is the dome tweeter. There's also a couple other designs. There are inverted domes, there's ring radiators. They all have kind of their advantages and disadvantages, but the dome tweeter, whether it be like a silk dome, aluminum dome, titanium dome, just has the best kind of response that we're going for, and that's why it's kind of become standard in most like high-end hi-fi speakers. But the dome tweeter is just not good enough for our pro sound level, and it's because dome tweeters have limited output. Typically they're going to be less than 96 dB per watt. Usually they're going to be only around 88 to 93, so they're generally going to need like 4 to 6 times more power. Maybe, no, let's see, 96 dB minus 88, that's a lot. That's 8 dB. 8 dB is almost 6 times, 7 times the power according to those equations that I showed you earlier. But that's still a lot of power that you have to dedicate to the tweeter, and that's actually why the Funktion One F81 has such a high crossover frequency. It's just to be able to allow high power handling for long term, but that's at the expense of like several different sound quality hits. And I'd rather have the sound quality than the high power handling because we're not running as much watts as a nightclub. Again, we're not doing full PA speaker style output here. We're doing party speakers. So generally a 1-inch dome is gonna only handle 25 watts power handling, so if we cross that over too low, the dome is just gonna fail on us. So yeah, coupled with the low efficiencies means dome tweeters are taking a beating at high output. The Pro, they're simple to implement, the Con limited at high output. Now, when we're going with Pro style speakers, we just need the compression driver. This is much more efficient, but it requires a horn to spread the sound out, to have a good dispersion. And the Rockville horn has a pretty good like dispersion. From what I'm hearing, it's around 40 to 60 degrees dispersion off center, and that's pretty wide. I mean, it's not as good as a dome, which can get like 70 to 80 degrees of response from the center line. But the compression driver can be made larger and more powerful. The compression from the phase plug increases efficiency by matching the acoustic impedance of the driver and air. Difficult concept to understand, but essentially what the compression is you're actually directing more air at a higher velocity to be able to basically push more air. And if you push more air, you're going to be louder. And if you push more air on the same power, because you're compressing it, you get a more efficient speaker. So the horn design is really important for frequency response and dispersion. And bigger horns generally are going to be able to play lower without the compression driver unloading. Small horns need to be crossed over high, and this is kind of the problem that we've got with the Funktion One. It's a small horn. It's only about 3 inches. It's a standard small compression driver, and in fact most pro audio people would really consider it in this case a super tweeter, because it's only covering about 5 kilohertz on up. They're driving 5 kilohertz into the woofer and using damping to basically flatten the frequency response, but then you get a lot of breakup sound. The breakup sound, it's so hard to describe, but it sounds as if human voices and things in that range are a little bit muddy, like they're playing or they're singing behind a curtain. You just don't get a coherent sound. Additionally, compression method is important to maintain frequency response, and we'll go over the various compression designs on the next slide. And then you got material. I believe titanium is the best for durability. There's a lot of arguments that titanium doesn't sound that good, it needs a lot of damping. But honestly, people grew up listening to that bright West Coast sound, and part of it, ironically, is actually the breakup modes of titanium, which happens to be around 8 kilohertz. The Funktion One's aluminum dome tweeter actually has a little more damping, and its breakup range is actually even higher, but I don't like the implementation of the compression design or the compression and the horn design, because both together seem to be giving like a lumpy frequency response above 10 kilohertz or so. I can hear it. You probably aren't even catching it, or some of you can't even hear that high. Especially the people who build speakers themselves and listen to them a lot and a long time at high volume. That's just destroying your hearing. I mean, I value my hearing. If a club is just too loud, I walk out. I mean, that's always disappointed me, especially when I had to pay a cover charge and the speakers just sound so bad and scream in my ears so hard. And this screaminess is, I don't know if you guys have experienced it, but it's when certain notes play, it's like the sound all of a sudden jumps from coming from the speaker to inside your ear, and it just sounds so loud and so harsh. And to me, I can't stand that. I already know if I keep hearing that, I'm going to be losing my hearing for the night. Yeah, so the titanium does suffer from some high frequency breakup, but it at this point is kind of associated with that clubby sound. Yeah, I refer to it actually as titanium zing. Titanium just has a unique sound signature to it. Yeah, and people practically expect it as part of that nightclub sound. Now we're getting into crossover design. That helps to phase align our sound in the crossover range. Crossovers aren't perfect. They actually, like when we say they cut off at like 3500 hertz, that's a minus 3 dB point at 3500 hertz. And below that, like at 3000 hertz, and this is based on octaves, the Linkwitz-Riley second order is going to be dropping 12 dB per octave. So you're going to be only 12 dB down at half of 3500, or about like 1700 hertz or so. You're 12 dB down. So essentially you're getting some leakage outside of this crossover range, and from the woofer you're going to get some leakage above its crossover range. So this ends up adding to a lump in response. You can combine this with the rising response typically associated with 8-inch woofers, which tend to start right around like 2 kilohertz or so. This is due to just basically physics. And all woofers will beam because it's a baffle step kind of response. Essentially, higher frequencies will beam because you have a large surface radiating it. There's a lot of physics involved in here, and you guys are just going to have to research it on your own because you're just going to have to understand, essentially, I would call it Lambertian wave functions. It's about like constructive and destructive interference caused by a phase misalignment of the speed of sound between paper and air. Yeah, it's again pretty in the weeds, but just trust me, it happens. Woofers beam. A lot of speaker designers know that, but they don't really know how to compensate for it. And the only way to compensate for it is to cut out those beaming frequencies or introduce a phase lens. Phase lens is kind of what the Funktion One looks like it's implementing. It's a kind of a conical projection, but it needs to be at the right phase alignment, which means it needs to be in a fixed point relative to the moving waveform. There's also phase plugs for woofers, and essentially it spreads out sound that would be beaming by reflecting it outwards. So there's a lot of different ways to compensate, and again, there's always pros and cons to implementing each one because each one will affect one of these parameters. So you got to balance out what priorities you want in terms of speaker design. So achieving impulse decay. So the best way to do this, it's achievable with high stiffness driver material, but high stiffness driver material will tend to either ring or be heavy. So effective damping helps to minimize the reactive components in the crossover too, because the electrical performance is also related to the mechanical performance of the woofer. These are all interrelated. They're not just facts and figures to adjust like in a vacuum. They all affect each other. This next area right here is basically a lot of tweeter related design. So the Rockville has a titanium diaphragm. That's great. I like titanium diaphragms. JBL pioneered the use of good titanium diaphragms, but in their lower end stuff, and I'm talking their party boxes and even the higher end PRXs, they are plastic domes. I consider that bad. I mean, like they're using the plastic because honestly, I think their phase plug design is a little bit to be desired. They're not gonna tell you all the ins and outs of basically why they have their phase plug design the way they did, but honestly, it's a cost thing. Good phase plugs are difficult to machine, and that's actually going to be the majority of the cost in a good tweeter. You can try injection molding or machining. JBL chooses to machine metal, but machining metal is a lot more expensive than just injection molding a decent plastic phase plug. You're going to get like a better design with less manufacturing issues than trying to machine out a solid chunk of aluminum, and that's the reason why JBL has what I call their roulette wheel design versus the concentric ring annular design. So the neat thing is the Funktion One has a Celestion CDX1 1415 tweeter or compression driver. It's good. Aluminum is good, but it's not that durable at high power, and that's the reason why they're crossing it over so high. Not only because they're using, for some reason, a small tweeter or a small horn on their tweeter, but the annular design is good. It's actually designed to play down to 1500 Hertz, and the phase plug like shows it. It's a long horn phase plug, but that physically misaligns the driver. The tweeter alignment here, the horn depth aligns the tweeter physically. So in that crossover range that we're talking about, there's going to be an angle associated with it, which the crossover induces. If you align the voice coils like this, you can see the magnets are aligned on the tweeter because the horn has a depth to it. The crossover lobe here ends up putting a straight line where that crossover lobe is, and that makes it really nice because you can just aim the speaker up high and you're going to be able to hear clear sound without this lobe screaming at you. If you have this dome tweeter here, you may have good frequency response, but now you have a misaligned lobe. What this means is you got to put the speaker up even higher to be able to get an even response to your audience. This is more important to the people who are sitting up close because this crossover lobe basically has additional response from both the tweeter and woofer. So the tweeter and woofer are playing like within that crossover range extra loud here. So it's going to be screaming here, and this screaminess is going to be kind of misaligned. So that means that if you're facing the front here, the sound from the tweeter comes to you too early. Now the Funktion One F81 with its extra long phase plug actually puts the voice coil behind the magnet, especially because it's a shallower woofer, a smaller, like a shallower magnet that you're going to see when I take these speakers apart. So yeah, a straight on tweeter is sound aligned with the woofer. Crossover lobe's easier to deal with. It actually shrinks the crossover range because these are physically aligned. The downward sloping crossover from having a misaligned tweeter, that just makes the sound less coherent. It's really noticeable in real life if you're really used to hearing this stuff. So yeah, the sound from the tweeter will hit the listeners first, and there's a slight high frequency phase misalignment. This you can't just DSP out because these speakers have a passive crossover. You'll be able to do it with a DSP, but now you need the expensive DSP, bi-amp your speakers. It's just a lot more expensive to implement, so just make the crossover right, time align your speakers, and the happy accident is the correct size horn will allow time alignment and good frequency response without unloading the compression driver. So the compression driver, this is not a bullseye. You're going to see some close-ups. They're covered with a screen when I show you the actual compression driver. They're going to be covered up with a screen because we don't want bugs getting in there. That's a common thing that I've had to repair. People rip out these screens because they don't want it getting in the way of their sound, and bugs end up laying their eggs there. It's a guarantee. Especially if you run outdoors, some bugs are going to fly in there and then they're going to lay their eggs, and it's just going to rot the whole thing. Because you're going to get buzzing, the eggs are going to leave shells. It's just nasty. But that's a top view or a front view of it. It actually looks like this. These are actually concentric circles. This is the actual diaphragm, titanium on the RSG84, aluminum on the Funktion One F81. But these are called annular. They're also called circular. They're the best kind of compression driver phase plug because it allows high frequencies to get out. You can see that there's very short paths before the sound gets out. And this is very important that we keep the paths short. And that allows high frequencies to not cancel themselves out in the space between the exits. There's also another style called radial. These were easier to make, and it was actually a patent dodge by the people who, I believe it was KLH, who adopted this design, and it offers about the same amount of compression as these annulars, but cheaper to make. Big problem with this is that now you have different path lengths. There's a speed of sound problem that happens when the sound wave goes from the outside to the inside, and they'll actually destructively interfere in the passageways that are open. This won't happen because this is a circle, just like the dome is a circle. These are spokes, so that means this area will be not time aligned with this area. These plugs time align all of that so that there's no destructive interference. Now here's the big problem. This is the roulette wheel. This is actually a design for a ring radiator compression driver, but for some reason in JBL's 2414H driver, there's just a bunch of holes. This is kind of combining the worst of both worlds. It's got a circular ring here, which will allow some high frequencies out, but the compression design here lets a lot of destructive interference happen with the high frequencies. So I hear it on the JBL 2414 that up to 16 kilohertz, it's just sloping downwards. It peaks at around 10 kilohertz and just is -6 to -10 dB, honestly, at 16 kilohertz. So some of you can't even hear that high, but it takes away what is called airiness from the tweeter. It's just, it sounds dull. And kind of JBL's excuse is, well, if we're projecting sound far away, the air itself is going to dissipate those high frequencies. Well, that's all great and good for pro audio, but they're putting these 2414Hs in the Party Box 1000 and implementing too small a horn. So that means they're either unloading their tweeter, which will cause distortion, or they're crossing their tweeter over high at around 5, maybe 7 kilohertz. That'll keep your compression like tweeter alive, but you're now again running too high a frequency and causing breakup distortion in the woofer. So again, not ideal. Not only that, the reason why the 2414H has to have a plastic dome is this phase plug. This puts a lot of extra pressure in this area, which tends to be furthest away from the voice coil. So if you're far away from the voice coil and have a high pressure there, it will tend to fatigue metal. And so you put a lot of power into this compression driver. Aluminum will buckle, titanium will buckle, but plastic won't. It's flexible. But that also leads to breakup sounds in the plastic. And breakup sounds in the plastic just make this particular roulette wheel style tweeter just sound dull. Yeah, so yeah, the plastic diaphragm is needed because the aluminum would fail under the high compression pressure. With the uneven diaphragm loading, even titanium would buckle. And titanium is even more expensive than aluminum. It's hard to work with. And the uneven loading makes titanium ring even worse and sound harsh. So you need to have, in order for titanium tweeters to sound good, you need this kind of compression driver. Oh, and one of the other things that I know that JBL does with their roulette wheel, it's a very high compression tweeter. It has a good efficiency. It's like 105 dB response, and that's kind of needed if you want to match that with a 15-inch woofer and a very large horn and just essentially push the frequency response of this tweeter down. So it is good at lower frequencies, but we're not using the lower frequency response because we have a small 8-inch woofer that can respond all the way up to around 3,000 to 3,500 hertz cleanly. So we can actually lower the amount of compression, which lowers the stress, but it also lowers the efficiency to honestly around 99 dB. But our woofers are only 94 dB effective. There's actually a 3 ohm L pad added to the Rockville RSG84. So really the amplifier is seeing an 11 ohm tweeter because it's efficient enough, but not so efficient at 105 that we have to like pad down the tweeter a lot, because the more we pad down the tweeter, the less control the amplifier will have over the tweeter, and the more the crossover will have control of the tweeter, and that leads to ringing and poor impulse decay performance, because now we're having the reactive components take control of the compression driver and rather than the amplifier. So again, a whole bunch, there's a whole chain where the signal goes through, that there are opportunities to basically either drop the ball on sound quality or pick a good compromise to maintain sound quality. So the next area in the chain, you've got your input, you've got your amplifier, then you've got your crossover, then you've got your speakers. All of those are interrelated. All of the electromechanical performance has to be taken as a holistic whole. You can't just focus on one aspect of sound quality if you want to design a really good sounding speaker that will record well. So again, in woofers, we're going to talk about what makes a woofer good. PA typically uses paper, and there's nothing wrong with paper. Some of the best speakers in the world, like JBL, has used paper. It's not that hard a technology to master. It's the best compromise of stiffness and inherent damping. That damping is important because when speakers start to break up, they ring. They kind of, they sound muddy. They sound like the sound is coming from behind a curtain, even though the speaker's right in front of you. But they don't have these big old peaks and dips like ultra stiff woofers do. And we're talking about like carbon fiber, fiberglass, Kevlar, any of your hard materials, especially metal. When the metal breaks up and rings, the frequency response spikes and dips and spikes and dips after the breakup range. And that has to be dealt with extra damping on the stiff woofers, and that just leads to more weight and less efficiency. So yeah, the best compromise is paper because it's naturally damped. So yeah, many other many other materials and motor system modifications exist. I mean, there are even what are called shorting rings, and that reduces inductance of the electrical component in the voice coil of the driver. Both tweeters and woofers would benefit with shorting rings, but they cost a lot to implement. They significantly increase the price of the woofer, and there's a hit. There's a hit to efficiency because you're taking away some of the magnetic motor or the motor force in the magnet, because you have to machine away steel to replace with copper or aluminum. PA speakers need to focus on efficiency, so we don't need excessive inductance control. So it makes PA speakers typically similar. There's no radical technology being implemented in PA speakers because honestly, it's not really needed. We don't need ultra high fidelity sound in a club. There's going to be just too much noise, not the ideal listening environment, and not even stereo. So imaging is not going to be that big a deal. It's going to be mostly about frequency response and phase response, making sure things are time aligned, and that's the thing that's going to allow your PA speakers to be more intelligible. Paper cones can also have added materials. My JBL P1020D subwoofer, and this is a vintage classic subwoofer that I managed to get from a guy who closed down an audio shop and had these just sitting in the back, new in box. So rare. But this paper cone, it just looks like paper, but it actually has fiberglass in it. And it also has Kevlar. So this pulp is reinforced. It's very stiff. The Celestion TF0818, which is in the Funktion One, has thicker paper, and it looks to have wool added. Yeah, that's typical of British paper speakers. So that's just a thing. Offers more damping, increases the weight though, so you have to put in a more powerful motor. So the way they put in a more powerful motor is they kind of took away the bass response to be able to put a shorter voice coil, which allows the motor to become more efficient, but more efficient woofers tend to have less bass. The Rockville has a smaller, lighter 1-inch voice or 1.5-inch voice coil, less power handling than the 1.75-inch voice coil on the Celestion that the Funktion One has, but it can be made more efficient with lighter, thinner paper cone, but the thin cone increases cone breakup. That's the screaminess you're hearing that we need to adjust the crossover. So yeah, the screamy sound, got to be crossed over. Got to take that out because it's screaming in my ear when I'm near these. So here's a tip. Use Johnson paste wax. It's waterproof. and prevents browning. I'm going to show a little demonstration video because I like using this stuff. This is Johnson paste wax. It's actually for wood floors and furniture, but paper is made from wood, and I actually use this on my leather jackets too. So you can see it's wood, metal, leather, and plastic. It's just a good wax. It doesn't change the color of your speaker. It in fact looks identical, but the difference is you brush it on with a paintbrush, and I use a shoe shine brush to remove any excess. But it waterproofs the speaker a lot, and that helps it deal with humidity, and most of all, it stops the speakers from browning. So it keeps your speakers looking good for a long time. I actually reapply this every couple years to my paper speakers, and they always look brand new. A lot of people ask me what's my secret, and it's like, well, I learned this from an old head repair guy. And I mean, I already had this stuff because I ride a motorcycle, and this is great for a leather jacket too. So I like using this stuff for a lot, or for a lot of different uses. Paper speakers are just one additional use. Okay, so in the next set of videos, we're going to be focusing on subwoofers, but now we're going to be going on to the sound test. And this is the actual amplifier I'm using. So this is the Knob Sound NS03G sub that I showed you in the previous amplifier and power supply video. And you can see I built this switch here that has two different outputs. So the sound you're hearing is a side-by-side exact same signal going into each speaker. So you can kind of hear that the Rockville's a little bit louder, but that's the whole reason why we picked a 4 ohm speaker. It's gonna be it's gonna draw more power out of the necessarily lower voltage that we're using in this amplifier. It's run on 24 volts, but 24 volts is plenty when you're doubling up that power, and we're doubling up the power by lowering the impedance. This also has other effects. Basically, it makes the crossovers more expensive, and the crossovers that you implement, if you don't use high quality inductors, it's going to add too much resistance, and you're going to lose some cone control in the woofer. So we don't want to add too many crossover components on a 4 ohm speaker because it's going to get really expensive. All the values end up being twice as big as what's required for an 8 ohm speaker. So these are harder to, or more expensive to implement proper crossovers on, so we're not putting the bandpass on there. And we don't need it because it's a long throw 5mm excursion woofer, which will be able to handle more bass frequencies than the Funktion One, which needs its first order crossover. But that first order crossover, like I said, reduces the efficiency of the Funktion One, and this second order also reduces the efficiency of the Rockville. But there's kind of, again, a happy accident that essentially the sound that people got used to with JBL's club sound actually has about a 3 dB boost on the tweeter. And that in the old days, the tweeters didn't have poor frequency response. The titanium compression drivers from the 1970s were not only efficient, they were designed with the better phase plug, so you get the airiness, you get a flat frequency response up close, up to like 18 kilohertz. JBL was really good at designing these titanium tweeters, but now you only find them on SRX line and above. So that kind of sucks. You have to upgrade your already expensive JBL tweeters with upgrade JBL compression drivers, which just ups the cost even more because they're not cheap. The fact that Rockville included a titanium compression driver with the proper annular tweeters at a price point like this, I mean, a single JBL compression driver that's as good performing or as good a sound quality as the RSG84 is going to cost more than the RSG84. So again, we're picking and choosing our battles. We don't need the full pro sound level, so we can focus on sound quality, and it seems Rockville has almost got it, but they dropped the ball they dropped the ball by not completing their crossover. Okay, I'm going to be pointing to the speaker that I switched to, and we're going to be switching from the Rockville RSG84 with my crossover mod to a stock Funktion One 81. Head on, you're going to hear that, or at least I can hear very clearly how much better this speaker sounds now with the crossover mod compared to the stock crossover in this speaker. And also, I'm going to be turning it on its side like this, so you can hear the dispersion when I switch between these two. And I think you'll hear distinctly that the dispersion on this is a lot better than the dispersion on this. And this matters more when you're really playing indoor venues, because any sounds from this speaker are going to sound more realistic. Because you don't just listen to a speaker in an anechoic chamber, or honestly a lot of times outdoors. There's going to be a lot more sound bouncing off the walls realistically, so a saxophone playing here will sound more realistic in room than a saxophone playing here. In fact, it should, if your speakers were perfect, sound like the original instrument in the room. And that's kind of the purpose of getting the sound quality improvement through dispersion, because now anyone who pulls out their phone, no matter where they are in the room, are going to capture a realistic image of both the instrument coming from the speaker and the reflected sound waves to make it sound like it's an instrument in the room. Okay, I'm getting it lined up here so we're directly in front of that microphone. And I'm about to start this test.